All right, so continuing with solving radical equations. And so remember radical, that could be cube root or square root. We have already solved square root. And so 1 through 8 on this worksheet will be just some review problems. The new part will be the cube root equations, which start with number 9. And so, I'm going to do a few of the square root and leave the rest for you to do on your own, mainly the ones with extraneous solutions. And so for number 1, the first thing you want to do is isolate the radical, which is right here. And so the first thing you want to do is add 9 to both sides. And so you end up with square root of x equals positive 8. Square root is allowed to equal a positive number, but not a negative number. So by adding this 9 here, we took care of the negative. And so now we just need to square both sides. And so x equals 64. And if you plug 64 into this radical, you get 8 minus 9, which is negative 1. So this one works. Okay, I'm going to skip number 2 and leave that for you. For number 3, be very careful. It's very tempting to go ahead and add 6 plus 2 and get 8. But PEMDAS, order of operations, says we have to multiply, then add. So you can't do that. You cannot combine the 6 and the 2. And so what you have to do first is get rid of the 6 by subtracting it from both sides, giving you 2 square root, and you don't have to put that dot there. It still means times. Okay, and so then next we have to still isolate the radical by dividing by 2. And then now to get rid of this square root, we square both sides. 1 squared is just 1. Then add 3 to both sides and you get 4. Okay, you can plug 4 in right here. You end up getting a 1 from this radical. Times 2 is 2. Plus the 6 would give you 8. So that one works. Okay, moving on to number 4. This is a more difficult one because we're going to end up having to square this binomial. Okay, this radical is already isolated, so we do have to go ahead and square both sides. The radical cancels over here, leaving us with 7x plus 15 on the right. But on the left, we have x plus 1 squared, which I like to write as x plus 1 times x plus 1. You can use the box method to multiply that out. It would be x squared plus 2x plus 1. Don't lose that middle term. And so we are dealing with a quadratic. That means we have to get everything on one side. And so we are going to subtract 7x, subtract 15 to give us 0 on the right, x squared minus 5x minus 14 on the left side. And so I need two numbers that multiply to negative 14, add to negative 5. 7 and 2 will work as long as the 7 is negative. So that factors to x minus 7, x plus 2. And so x equals positive 7 or x equals negative 2. Okay, we do have to check these. Okay, if I plug in this negative 2, I'm going to get a negative 1 on the left side of the equation. And I'm going to get a negative 14 plus 15 under the radical, which I know will not work because a radical's positive square root cannot equal a negative number. And so this is extraneous. Okay, so on a test, if they ask for the extraneous solution, you're going to type in negative 2. Let's check the x equals 7. Okay, if I plug that into the left side of the equation, I would get 8. If I plug it into the right side of the equation, I get 49 plus 15, which is square root of 64, so the 7 works. And so if it asks for the real solution or the true solution, it would be 7. If it asks for the extraneous solution, you type in -2. Okay, I'm going to skip number 5, leave that for you. And I think you can handle the rest. Be sure to check for extraneous solutions on 6, 7. Well, just always check your solutions, but for 6 and 7 for sure. Anytime you have a square root equal to a linear, that's when those extraneous solutions pop up the most. Okay, and so now I am going to do 9 through 12 because these are cube root. And cube root is always going to be so much easier than square root because the domain and range is all real numbers. You don't have to worry about extraneous solutions for these, but they do come up, so you do want to check your solutions. And usually they come up when you plug something in. You'll see an example like that on the practice. But for now, let's just do 9 through 12. Okay, so here we have cube root equal to cube root. And so basically you can ignore the cube root or cube both sides. And we're left with this linear equation. So get your x's on one side, constants on the other, and x equals -8. You can plug that in and it will work on both sides. I'm not going to do that. Well, let's do it. Okay, we get cube root of -24 minus -24 plus 7 on the left side. And then on the right side, we get -16 minus 1. That gives me cube root of -17 on the left, cube root of -17 on the right. That's not a rational number, but they are equal on both sides. And so the -8 works. Okay, for number 10, we just have one cube root. And so it is already isolated, so I can cube both sides. Leaving me with this x squared plus 2x minus 7 equals 8. Okay, and so then I'm dealing with a quadratic again, so I need to get everything on one side. And then I need two numbers that multiply to -15 but add to 2. 3 and 5 will work as long as the 3 is negative. Okay, so I end up with x equals 3 and x equals -5 as my possible solutions. So let's check both of them. So starting with the x equals 3, I would get cube root of 9 plus 6 minus 7, which is cube root of 8, which is 2. And that matches the right-hand side. And so x equals 3 is a true solution. Next, let's check x equals -5. I would get cube root of 25 minus 10 minus 7, which is 15 cube root of 8, which is 2. Which matches the right-hand side. And so x equals -5 also works. Okay, number 11, we've got x's on both sides. We've got a cube root, and it's isolated. And so we can go ahead and cube both sides. It cancels over here. And so I'm just left with an x on the left side and an x cubed on the right side. Okay, so in order to solve this, it's similar to the way you would solve a quadratic. When you have a cubic equation, you still want to move everything to one side. And so I'm going to subtract x from both sides because I want a positive x cubed term. Okay, and so next I can factor, just like I would a quadratic, I can factor out an x. Okay, and then that leaves me with a quadratic that is a difference of squares. It factors to x plus 1, x minus 1. And I still have this x here. Okay, so I have factored this cubic. We've learned how to factor cubics last semester towards the end. And so that's where it comes into play if you want to solve a cubic equation. And so we still have to set each factor equal to 0. And so x equals 0, x plus 1 equals 0, and x minus 1 equals 0. In this case, I've got my solution. In this case, subtract 1. In this case, add 1. Okay, and all of these solutions do work. If you were to plug them back in, the cube root of 0 is 0. So that one works. The cube root of -1 is -1. And the cube root of 1 is 1. So basically this equation says, okay, which numbers have a cube root that is equal to the original number, which is 0, -1, and 1. All right, last one. We've got our cube root. Let me get my highlighter right here. So we need to isolate what I just highlighted. And so order of operation, you have to get rid of what is not attached to your radical first, kind of like reverse PEMDAS. So the first thing you have to do here is subtract 3. Switch back to purple. And so I'm left with 2 cube root. Be careful how big you do this index of 3. It could turn into looking like multiplication, so just be careful about that. I've seen it. Okay, so now we can divide by this 2. So cube root of 4x minus 5 equals -2. And remember, it's okay for a cube root to equal a negative number. It is not okay for a square root to equal a negative number. The range of a cube root is all real numbers. You're allowed to get negatives again. Okay, and so now to undo that, I cube both sides, leaving me with 4x minus 5 on the left. -2 cubed is -8. Don't say +8. You will miss it. Add 5. And divide by 4. Okay, x equals -3/4. This one does work if you plug it in. 4 times -3/4 is -3. Let's switch to blue. So I end up with -3 minus 5 plus 3 under the radical, which is -8 under the radical. Cube root of -8 is -2. 2 times -2 is -4. -4 plus 3 is -1, which matches the right-hand side. Okay, and so on a test, it would probably say type in fraction form, simplest. So just double check when you get a fraction, make sure it's as simple as it can possibly be. Don't leave something like -6/8. You would miss the problem if you left that. Okay, so you need to do this 2, 5, 6, 7, 8, and the back. I will post the answer key on the next page for you to be able to check.